And I see that the live stream is preparing. And I see that the live stream is preparing. Okay. I see that the live stream is preparing.
Oh my gosh.
Okay. Good afternoon, everyone. Sorry, I don't know what's. Good afternoon, everyone. I want to welcome you to AI Talks this afternoon. Thank you for joining us. We're looking forward to hearing from, and I want to welcome Eunsu Kang, who is here from the Carnegie Mellon University. Just before we do that introduction, though, I would like to begin with our land acknowledgement. It's my pleasure, and I'm grateful for this opportunity to recognize the many Indigenous nations that have long-standing relationships with the territories upon which York University campuses are located that precede the establishment of York University. York University acknowledges its presence on the traditional territory of many Indigenous nations. This area, known as Tkaronto, has been caretaken by the Nishnawbe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities, and we acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. This territory is subject to the Dish with One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region that we are now very grateful for. In addition, we in the Department of Computational Arts and AMPD would also like to acknowledge that the virtual networks on which our activities and gatherings are sited is a product of Silicon Valley and the Zoom headquarters, which are located on the Muwekma and Ohlone territories. Thank you. With that, I'm now going to turn the proceedings over to Joel Ong, who will introduce our guest.
Hi, everyone, and thank you so much, Michael. I'd like to extend our greetings here at the Digital Media Program, as well as Sensorium, the Center for Digital Art and Technology. And we're really, really happy to have Eunsu here with us today. Eunsu is a familiar face for some of us, and also a longtime friend and collaborator with myself and some of the people in our department as well. So Eunsu is an artist, researcher, and educator who explores the intersection of art and machine learning, as well as the possibilities of creative AI. She began her career as an artist making single-channel videos and video installations, and after more than 100 exhibitions in countries around the world, including Korea, Japan, China, Switzerland, Sweden, France, Germany, and the US, her works have transformed into interactive and interdisciplinary artworks, which currently focus on the nascent area of AI art. Her works have been presented at conferences including ACM, ICMC, ISEA, SIGGRAPH Asia, and NeurIPS. Kang earned her Ph.D. from DXARTS at the University of Washington and now teaches courses such as art and machine learning and creative AI at the Machine Learning Department of Carnegie Mellon University. And recently, she co-founded the Women and Art AI Collective. So without further ado, please join me in welcoming Eunsu. Thank you.
Thank you, Joel. Thank you so much. Thank to the York University inviting me, having me here. Should I share my screen? Okay, sharing screen. Okay, again, thank you so much. This is really great AI talk series. So, well, I was looking at the weather. I was telling Michael that we had the first snow shower today in Pittsburgh. So I was checking the weather in Toronto and Pittsburgh. It looks pretty similar, actually, pretty similar. And recently, have you noticed that the weather report has been pretty accurate? I check it every day and for the week, and it's very, very close to be true. Comparing to when I was growing up, we were making fun of the weather prediction because that was so wrong all the time. And things, the reason why we have more accurate weather prediction now is that we have accumulated a lot of data first, and then we probably have a lot better algorithm for the prediction. What machine learning does is something like that. I'm saying machine learning because I'm guessing everyone read that word, at least in my abstraction, or you've heard of it. When we talk about AI art, in my case, only method I know in AI field is machine learning, which is one of the methods for developing AI systems. So what machine learning does is using the data, accumulated data, predicting something, right? Oh, before I get there, so we can think about that. We can predict stock market change. We can predict how you're going to finish your sentence. We can predict what kind of song you want to listen after these type of songs. Then you can also the system can predict what kind of desk you would like to buy, etc. Also, you can think that we can probably predict how the disease spread. And it's been very successful with flu. My colleague, who is a director of machine learning department at Carnegie Mellon University, Ronnie Rosenfield, he and his group have been very successful with predicting how the seasonal flu spread every year. So the CDC thought, okay, maybe we can use it for COVID, how COVID-19 spread, and we can predict and we can prepare better. What do you think about that? I want to hear from you. Do you think that would work? The CDC idea of using machine learning? Can anyone answer to me, either using your microphone or chat?
It certainly seems, Eunsu, like it's something that could work.
You think so? Anyone else having any other thought?
Well, yeah, it's matching a pattern, not necessarily making a second order decision about the content of the pattern, right? So this is very well suited.
Okay. Anyone else? Okay, I'll move on. Here is the answer. Unfortunately, CDC and scientists thought that would be a good idea. But Ronnie, who is the expert in that, he didn't think so because, like I said before, for machine learning, you need a good amount of data accumulated over time. With COVID-19, we do not have that because it just happened. With seasonal flu, we have 20 years, like he says, 20 years of data. With COVID-19, we don't have any data that we can learn from, so the machine learning algorithm can predict. So this is the limitation. I don't want to call it limitation, but this is what machine learning is. Then how do we use it for art, right? We know that now we know that machine learning needs big data set, and then algorithm that learn from the data set and make predictions. How do we use it for art? What does machine learning do? Do with art, typo, do with art. Let's see, in 2017 June, a group of Professor Algamel and his team developed an algorithm called CAN, Creative Adversarial Networks. And they did a survey asking people between those painting images they generated using their algorithm and those images from the photos of paintings from Miami Art Basel. You might know Miami Art Basel. It's a very famous art market. Those artists invited to that Basel are very renowned ones, right? Then they got really surprising results. Apparently, people favored generate the images over those famous artwork images. Of course, there is something we need to recognize, that they were using tiny thumbnail of an artwork, not really showing the artwork, the material, the size, texture in person. So lots of important part of the artwork was missing in this comparison. However, even with the thumbnails, we were very surprised in 2017. In 2018 May, Cloud Painter, that is that robot arm. There is a robot art competition every year now, and you will be really surprised if you look up the winners' paintings. They are certainly better than most human artists, in my opinion. So these robot artists prove that machine can achieve the aesthetical level of professional painters for sure. And they are using real canvas and paints, as you can see. And the machine learning, what machine learning does in this case is it works like a brain. So the algorithm analyzes input image and decide how, what, and how it will paint. Then robot arm follows the direction and then finishes the work. In 2018 October, you might have heard of this. The artist group called Obvious, the 3 French young men, they generate an image like this, and they sold it for almost $500,000 at Christie's auction.
I'm sorry to interrupt. I don't know how other people are, what other people are seeing, but I'm only seeing your title screen.
Really?
Yes. Is that the case for other people? Maybe people can give us a thumbs up. Okay.
Yep. We're only seeing the start.
Oh no, what's happening?
Well, maybe you could stop. Yeah, no, maybe you could stop sharing and reshare.
Yeah, I will reshare.
Kind of thought you were testing our transcribing skills, to be honest.
Yes. No.
Wait,
not yet.
Something is not right.
Yeah.
Share. Oh, and now I can see the chat. I couldn't see it earlier. And then this one, right? Can you see it?
Yes.
And I say play. Is it going down?
No.
Is it changing?
No, it's not changing.
Oh, that's so weird.
I wonder if there's another way to access rather than play.
Now, can you see?
Yep.
Changing? Okay,
Yes,
I'll just not use the play mode. Yeah, right. Okay. So,
yes.
let me see.
Can you get rid of those?
Get rid of this part? Yeah, that's what I'm trying.
Yeah.
Oh, yay, better.
There we go. That's better. And what happens if you click on document? Though I don't know if it'll.
Document.
No.
Okay,
Yeah.
I'll stay like this.
Yes, this will work. Thank you.
Yeah. So, so you've been seeing this and you missed this when I was saying thank you.
Great.
And you missed the weather, which is very similar between Pittsburgh and Toronto.
Great.
And this is that Brody Rosenfield's, our director's interview about the CDC request about coronavirus spread research. And he's been very successful with flu with 20 years worth of data, but he decided to go for some other method called wisdom of crowds because we don't have data for COVID-19. Right. And so that's my typo. What does machine learning do with art?
Perfect. Great.
Yep. So those are the GAN-generated images I was mentioning earlier. Mm-hmm. And this was compared with thumbnails of Miami Art Basel paintings. And people liked these generated images by machine learning algorithm better, at least in that survey. And this is the Cloud Painter, this robot arm. And they have actually not just Cloud Painter, but all the robot artists won this robot art competition in recent 5 years or so. Their works are really good. Definitely at least at the level of professionally trained painters level. And this is that controversial work by French artist Tim Obvious. You see this signature, that's actually a main function from GANs, Generative Adversarial Networks, developed by Ian Goodfellow and his other machine learning researchers. And so they were using this signature. So Christie was able to say, this is the first ever AI generated artwork, which is not true. Because even before that, I was generating portraits using GANs, and many other artists have done it too. But they were the first using the signature and had connection to Christie's. So these things have been happened, right? So certainly something has been happening between art and machine learning. And how is this possible? So that's that famous GANs that was developed in 2014. It's called Generative Adversarial Networks because it has two networks. So when we say machine learning algorithms, those are neural networks. You've heard of deep learning. Deep learning is the network is actually having many layers, going deep, very long, or sideways, going long. Well, we just see it vertically and say it's deep. And some networks just have 2, 3 layers of it. And in this case, this algorithm has two networks inside together. One is generator, the other is discriminator. What happens is that from the latent space, basically noise, noise comes in, generator tries to make, let's say the goal is making portraits, right? It's trying to paint a portrait, but it knows nothing what portrait is, what human face looks like. And so it just creates some noise. Then discriminator looks at it, and discriminator is connected to all the real human face photos or portrait images. So discriminator knows what it is like. And this discriminator tells the generator, no, that's not it, it's far from what it is. Or, oh, maybe this way a little bit, that way a little bit. So it fine tunes what generator generates. So eventually, after many iterations, generator creates a very realistic human face or portrait. So this is the famous GANs. Until now, probably the most popular, one of the most popular algorithms in machine learning. The other famous one happened in 2015, actually. It's DeepDream. So for example, this is from my class slide. So the DeepDream, basically what happens is that it targets certain layer, certain feature, and amplify that feature. So the targeted feature is, for example, like flower-like piece feature. Then you will see that everywhere, amplified. If it's from noise, just that pattern. If it's from an existing image like this, then it finds where it has similarity and then exaggerate and amplifies that feature more. So starting from this landscape photo, after some iterations, many iterations actually, you can start see some animal shapes emerging because it was targeting this layer MIXED4C, which is about animal-like features. So when it came out, the articles titles were like, now we know how machines dream. I mean, what's in machines' dreams. And it's really fun, interesting algorithm to play with. So that was a huge provocation to artists. And the other thing, one of the most famous popular algorithm that's been used by many visual artists is style transfer. So bottom line, now there are a lot of different iterations of style transfer algorithms, and there has been many advancements. But this is the first one. the original one in 2015. So as you can see, there is a picture, photo, and it can transfer style. Here, what they mean by the style is color scheme and the brush stroke style, like part of texture, but not really entirely artist style in the context of visual art. However, so Turner's work, the style was transferred, and Van Gogh's work was transferred, and Munch's work style was transferred. As you can see, it's very, very successful. And artists have been using this as not only trying to make images, but it also can apply to videos. So for example, transferring my drawing style to a video, something that's videotaped. So something like that's been happening. More recently, so because these are very first three that really struck artists and made artists can do coding to jump into this and play with it. In machine learning field, every month there are like thousands of papers are coming out, I think. So many developments happening. And one of the most recent ones, because I cannot introduce everything, one of the most recent one is this. It's also by my colleague in Robotics Institute, Jun Yanju. Something like this. You make a sketch of the cat, then the algorithm will generate a cat image as you see it at the bottom. In the pose you want to have. Like this. So there are these algorithms. And one of our colleague, friend, media artist Robert Toomey very recently created a work called Artificial Imagination. This is a part of a group work project, Machinic Sublime, which was started by our Professor Joel Ong. He uses all these three very popular algorithms right now. GPT-3 is the most recent text generation tool that everyone can easily access, right? And for text to image translation, clip, and image generation, GAN. So these are really very recently what visual artists in AI art field have been playing with. And you can see that about relationship with machines, there was this prompt sentence. In 1996, a family of robotic seals were brought into nursing homes in Japan to help the elderly cope with the after effects of a tsunami, partially written by our Professor Joel Ong. And GPT-3 generated these texts, extending the story. And then based on that, using clip and GAN, it generated corresponding images, a video now. So something like this is happening. Going back to a little old time. So you see this face, do you recognize her? And does anyone recognize her? Oh, shit. Okay, now I'm trying to read the, not me. Right. No one should not, because this is not a real person. This is one of the faces my students and I generated in 2018 or 19, long time ago. It's using algorithm called the PGGAN, Progressive Growing of GANs. That was one of the first high resolution face GANs. Before then, the resolution of GAN-generated images were pretty small, but this is one of the first high resolution ones. Now it's a lot more realistic. You see this smudged part? it doesn't exist. Now no one can tell if it's a real photo or generated photo. There's nothing you can tell about it. So we created this face and gave her name Miss Sun Lin to make it sound like a little Korean and maybe not, and having ML, machine learning, ML abbreviation, because she was the reporter of this fake news site. She's the writer of this fake news site we made in 2019. So we generate this text. Now we have GPT-3 and all trained models. Well, at that time, we were using LSTM, one of machine learning methods, and LSTM and generating these news articles. We were scraping articles about North Korea, American politics, fake news and journalism. And based on this data set, with using LSTM, we were generating new articles, such as this, like this. Everyone was, okay, let me see. Kim Jong-un clapped his hands as he, along with his wife and hundreds of other citizens, community. Yeah, it's using just LSTM, and our data set was not very big, so it's not very smooth. The point was doing this project was that we thought those news articles that's written with for some political propaganda, we thought they are, although they may be based on some facts, they are working like fake news. That's what we thought. So we wanted to generate real fake news and see how it works and how it's similar or different. So we can generate images, we can generate paintings, we can generate texts like poetry and novel, right? What else can we do? I'm not going to introduce any music example today because, no, there's sound example, but no music example, music composition example, because I haven't been successful with it. But there are companies successfully generated music as well. And the other thing we tried was generating 3D form sculpture. So the goal of this project was generating an authentic 3D form that does not mimic any given forms and cannot be easily categorized into the labels of the training data set. The training data set was really ordinary. So it has category of folder of like airplane, human, vase, guitar, desk, chair, toilet, something like that. So all these ordinary things are categorized. Usually researchers use that data set to successfully generate an airplane model, right? New airplane model, but it has all the details of real airplane. Usually that's the goal. But in this case, because we were trying to make our algorithm creative and then trying to generate an artwork, our goal was very different. So not this, not that. Well, when you can think, well, to create something different, maybe you can just combine A and B, like desk and airplane, and put them together. Then it's not desk, it's not airplane, it's something new. But really, many of your artists, you understand that that's not really how artists create artworks. There's A and B, we put together, and it becomes C, right? Not just A plus B. A plus B and C are totally different. So our goal was creating the C. So we had to develop some algorithms. We actually developed maybe 4, 5, 6 algorithms, small and big. And we ended up using this one, partitioned DeepDream. Let me explain from amalgamated DeepDream, ADD. We give it has a name DeepDream because we were inspired by the idea of 2D, two-dimensional DeepDream. So two-dimensional DeepDream, it targets certain feature, and using that feature amplifies that feature over and over and over and over. So it gets like more and more snake-like, more and more dog face-like, etc. We were using that idea using a point clouds. So as you might know, point clouds is one of the methods having virtual 3D forms, having lots of dots in 3D space. First of all, we combined two different objects, and then we were asking algorithm to target the other objects, the third object. So it would transform its shape to be the third one. So for example, if you look at this, input is cone, face, lamp, three different objects, and target was person. It's trying to be like person, although it starts from cone and base and lamp. But there was a problem. It was really the point cloud to be successfully stay as a form and print it out. It should have those points pretty equally distributed. And they were becoming very sparse while it was transformed, as you can see here. So to solve that problem, we were actually combining, amalgamating more forms together to have more dense point cloud form from the beginning. And also to have more details, instead of targeting the whole thing, just one target, we partitioned each part of the shape and asked each part target differently. So each part transforms more like if it's 2D, two-dimensional image, maybe it could be similar to the idea of making the resolution higher. So partitioning them and then transforming, when the target is airplane, when target is person, when target is ball, the results are different. Eventually, we got some interesting forms, but it was really, really, really difficult to turn into mesh and print out because the sparse point cloud problems. But eventually, we were able to get some forms printed out. So for example, this one, bottle, input is a bottle, upper target is human, lower target is toilet. I chose human and toilet just because I thought it could turn into something more interesting because of its shape. And we were using both pivoting method for mesh reconstruction after trying many different methods, and used the log spot that I have at home and had a result. Do you have any questions so far? Anything that was not explained enough, or
just a quick one, yeah. Eunsu, when you say human, were you targeting the whole human body as a form or some aspect of the body?
Oh, that's actually a whole human body. The data set has a whole human body, but not very detailed. Just like rough human body shape in point clouds.
Great, thank you.
Yeah, with 3D construction, we have a huge resolution problem because with two-dimensional images, now GPUs can handle very, very high resolution results. With 3D, it gets a lot higher, like a lot more computation. So it's still not very easy to make it very detailed. Of course, computer vision people are developing methods of going around it though. So once we have these 3D sculptures that had not that we think it's authentic form, we turn them into an art project called Orofana. So this work is done with Donald Craig, Austin Dill, Songwei Ji, and Barnabas Pochosh, and also Chun Liang Lee and Manju Jahir helped. So we were using ADD and PDD results like this, 3D printed, and those are the form, body of Orofana. Orofana, as it says, as it means, a creature made of sound, creature of sound. And also its sound was generated using WaveGAN algorithm that's developed by another researcher at UCSD. And then we added some interactions so it can react to the visitor's sound and touch. So this is a visitor. There is an iPad and trying to virtually touch the oral fauna. And when people are talking through a microphone, you might not see, but here is microphone. It also responds. I'll show you video very soon. And this oral fauna's interaction was actually inspired by Sirens of Titan, and the creature in that book, Harmoniums, a family of creatures that becomes alive when there is a sound or a touch fed into them. So these are two methods of interaction. Now I'm gonna show you video. I hope I shared sound. Please let me know if you can hear sound. Can you hear the sound?
No, we can't.
Okay, I'm gonna reshare. Share sound.
Hello? Who are you?
Yeah, that was an excerpt from the video. You probably noticed that oral fauna was responding how people speak to them. It's based on the idea that oral fauna is trying to talk with the human species. So they are trying to mimic what human says as the first step of learning about each other and the first step of communication. So, and then I wrote these questions. What is our relationship with the AI as creative machines now? I wrote these questions in the abstract for this talk. So I'm gonna go over these questions. To do that, one of my students and I looked into, studied what collaboration means in art field. It's a profound mutual effort that creates a third artistic identity superimposed over and exceeding the individual artists. Like I said before, not A plus B becoming C, not just A and B. So in terms of that, we examined AI art projects in recent years. And our conclusion so far is that we actually didn't get to the point of that we can call collaboration yet, but we can call it machinic surrogates. So proxies for skills, decisions, and biases of human agents embedded into the machine learning algorithms or AI systems. So human inspirers. So there is machinic surrogates of the human inspirer in the system. So it's not exactly human controls the machine. Also, it's not that human is completely disconnected from the machine, but there is this surrogacy happening together. And we also studied what kind of roles people are taking in AI art field. And we categorize them into design and the architecture input-output format, creating tools as an author, and repurposing the tool, like for example, GANs, curating new training data set, like we call them author user, and selecting input, fine-tuning parameters, user, evaluating outcomes, and then cherry picking which output you will present as an artwork, moderator, and audience interaction when it's an interactive work, audience interaction with the outputs, the audience. So all these people are being involved in turning one creative machine's outcome into an art project. And of course, it's not that someone is just an author, just a moderator. There could be a person who is user and moderator. There could be a person who is author and user and audience all together. So it's a spectrum, not exactly divisions. For example, that controversial work, that was the tool, the GANs was created by Ian Goodfellow's team, and Smith-Chintala made a DC GAN based on GANs, and then Roby Barrett made art DC GAN that uses artworks as a data set, and then obviously use their own data set and then generate this image. Then Christie's curators and experts decided that, okay, this should be called AI, artwork created by AI. And then there were some audiences voted. And then that happened. So all this complex system is creating that work together. But for me, I'm an optimist in terms of machine-human symbiotic ecology. I always think I'm studying these so I can better prepare or make our lives better, because we are already living in machine-human symbiotic ecology. So my collaborator, Donald Craig, and I made this work that's called The Guitarist and Oral Fauna. So now the oral fauna, those creatures having machine learning generated sounds and body shapes, having a duet for human and machine generated creatures. This is a very, very short excerpt. Yeah, it's very short, but the Donald Craig, the guitarist, and the oral fauna were corresponding to each other and having this duet performance in real time. The other approach I'm having with my students and colleagues are robotic painting. But when we got here and then the pandemic started and we stopped, I think it's time to get back to it. So the Miss Unlin, remember the Miss Unlin? This is the portrait of Miss Unlin. So what we tried was the machine learns how human artists make brush strokes. So by learning from certain persons, in this case him, certain persons' brush strokes, it learns the style of the brush stroke and generate its own, which is very similar to that person's style. And using that brush stroke, creating a portrait. I intentionally stopped it in the middle instead of becoming all the way to realistic face, because I wanted to see some more expressive result than just photorealistic result. So that's one of the things that we are trying right now. And what do we learn from working on or with AI? I'm gonna talk real fast because it's 4:45. So I really learned a lot from working on and with AI. I learned about who we are. I learned about what we should improve as human species, and also learn what it would be like if we have no bias in human society. So first, this is a very famous article titled in 2018, Facial Recognition is Accurate if you are a white guy. Because at the time, all these big companies, Google, Facebook, etc., they were using about the same data set that had 75% male and more than 80% white. So when they use that kind of data set, if you think about it, it's not reflecting the population of the world, right? So it would lean toward, oh, human face is more white face, right? That's what it learns, because that's what we taught. So with the inaccurate data set, the algorithm cannot learn it correctly. So having this kind of disastrous results. The data set I used was called CellLab A, because it's this research group scraped off lots of photos of celebrities from the internet. That one actually, maybe because it's celebrity, it has more white, young, female faces. And in terms of gender, it's not too far. It's similar to 50%. But in terms of ethnicity, it's definitely more white faces. I think it's actually, well, if you think about, okay, this is not an accurate reflection of our world population, right? But if you think about it, this is pretty accurate. It could be pretty accurate reflection of the biases we have, the celebrities, the Hollywood stars. There are definitely more white actors, actresses. And the other little detail I found from this research, and thought this is really accurate reflection of our own bias in human society, is that more female faces were smiling. So that really reminds me of that earlier generation, maybe even now in some cultures, like females are often more required to smile or put makeup or think about their appearance more, etc. Right? And I really thought, oh, this is very interestingly accurate but biased result. So it reflects our own bias, and now we know, oh, that's what we have. So using the CelebA data set, I was generating many different portraits. And again, the goal was creating an art piece at the time in 2017. So instead of trying to make a realistic result, I was trying to stop somewhere in the middle when it's still, in my opinion, ambiguous and alluring. So if you look at these, you can see some level of ambiguity, right? And the right one, interestingly, my husband and I were just casually talking, and he and I had different opinion about the gender of this person. So I asked my friend on social media, and 56 people said, oh, that looks like female. 29 said male, 5 were more hermaphrodite or androgyne, and 1 transgender, 1 for a Dutch person, probably because of this pose, the portrait pose, Dutch portrait. 1 for Pokemon, I noticed it because of the nose. Puppy, the same reason, I think is the nose. And 2 for David Bowie, which is very interestingly kind of good response, right? So the ambiguity of gender in this photo really intrigued me. And I looked at many other generated faces, and I found many that's ambiguous in terms of ethnicity and age as well, which is interesting because the data set I used was biased, but the generated result, before we cherry pick them, if you look at many of them, it actually goes through the whole spectrum while in the process of trying to learn what human face looks like. So I see some optimistic perspective. I find optimistic perspective from there. Okay, and what are the challenges for making creative AIs? Actually, frankly speaking, I regret that I added this question in my abstract, because this would be another whole new talk. This should be a separate talk. Actually, it was a course, a semester-long course that Dr. O at Robotics and I created, built in 2019. And in that class, so I'll just, I don't think I can cover really this question entirely, but I'll just quickly go over. So the questions we explored in the class are these. How do we computationally model ambiguity? Would a novelty search result in valuable discoveries? Where is the threshold between randomness and creativity? They should be different, right? It cannot be just random. We cannot call it creative. How do we evaluate the creativity of an algorithm? This is a problem in terms of engineering and computer science community, because to develop an algorithm, and you need to have a goal, and you need to know if it's working or not. To know if it's working or not, you need to be able to evaluate if it's doing what we want it to do. Then if we want to develop something creative, then we need to be able to evaluate if it's creative or not. And there is this big problem. Creativity is an ill-defined concept, very ill-defined. However, I'm gonna skip this. However, creativity involves a multitude of definitions and applied in varied contexts. So here is the hope that we got in our class as well. And now we are continuing this research because we can start from, we studied creativity in philosophy and all. There are many different kinds of creativities. So we can choose one little creativity that could apply to that algorithm we want to develop, that project. And then we try that. And hopefully another, and another, and maybe collectively we can get to some good idea of creativity eventually. So that effort we are putting on is mcreativeai.org. Right now we have those 3 workshops on the website. This website is kind of under construction, so we are developing it. We had workshops in SIGGRAPH and ISEA and CVPR. And soon we will change this to multi-institutional creative AI group, actually. Okay, so that, and it's a little abrupt, but I want to mention that I also co-founded womenarts.ai, just to share that there are women like me and them working in this little field. So we know each other, we know each other exists. So that's it. Yay, 7 minutes left.
That's great, Eunsu. Thank you very much. I very much appreciate your talk. And I guess what we'll do now is sort of open the floor to some questions. So I'm wondering if there are people out there who might have a question. You can ask it in the chat if you like, or you can just turn off your microphone and speak to us directly. Grace, I see your hand up.
Hi, thank you for that really inspiring talk. It was exciting. I have a question for you about GANs algorithms. When we increase the noise in the algorithm input, is it truly random, or is there a pattern to the random noise that we're inputting?
Actually, for GANs algorithm, the noise input, what it is, doesn't really matter. Because really what happens is based on how it learns the features from the discriminator. So the noise, whatever noise you give, it's not gonna change the result. But the other question, that's one question about GANs, but about the randomness and noise, all the randomness we are using in computation, they actually are patterns, right? So we actually can repeat them, as you might know. So philosophically, it's not random, but computationally, it's random. Does it make sense? Yeah,
yes, that makes sense. Thank you.
Yeah, computationally, it's random enough, really random enough to get the right result. But if we really say, is it really random? That's nothing like this would not exist. We cannot repeat. We can actually repeat.
That's great. Thank you. Are there other questions? I don't know that I have a question at the moment, Eunsu, but one of the things I was thinking about while watching your talk, and in particular, looking at the paintings, I was sort of thinking about the notion of mastery, and in the Beaux-Arts tradition of painting, there's this idea that over time people would master a set of skills. And, when I saw you using the robot to teach the brush strokes, I was reminded of Chinese brush painting, because I had an opportunity when I was much younger to spend time in China studying brush painting. And I remember, being taught a series of strokes, and each, the subject matter of bamboo or the lily was all created through a series of strokes. So in part, I'm reminded of that. I'm thinking about this notion of mastery, but then I'm thinking about you saying, you're suggesting that you were stopping the process. And as I said, I'm not sure I'm going to get to a question, but I guess I'm thinking about learning and unlearning. And I'm thinking about sometimes we say to students that we need to unlearn some of the things that we've learned in order to sort of move forward. And I'm wondering if there could be this idea that, you know, the algorithm would be taught to learn something and to master something, but then you might want to back it up and have them unlearn something in order to produce something that we might think of as more abstract or something that we might think of as more contemporary.
That's a really, really, really good point. Yeah, I think that's necessary for creativity. You cannot just try to reach the goal, right? So like in many examples in terms of computer science, the goal is making realistic face, realistic cat, realistic landscape. But we artists know that when we have that realistic result, that might not be an artwork, may or may not be. Then where is this creativity resides? Somewhere between that and, like you say, that unlearning process. And having its own, if it's a human artist's own style or own perspective, right? So that's, we are trying to find how we can do it computationally, which is very difficult. So I really like how you, your wording, I really like your wording, learning, unlearning. I think I might use it.
Yes, absolutely. You know, the other thing, and I see a question in the chat, so I'll move there in 1 second. But the other thing I was just thinking about too, when you talked about stopping the process early, because it seemed to look more like a contemporary artwork in some ways. I'm also reminded of us always telling our students to embrace the mistakes. Often if they're working toward a goal, along the way, they'll make a move, they'll make a decision, and they'll think, oh, I've made a mistake. That's not what I'm supposed to be doing. But instead, we sort of encourage them to step back for a moment and try to be open to that mistake, because that mistake might take them in new directions, in new ways of thinking about what it is that they're doing.
Right.
But I'll stop there. And I noticed that Eyal has asked a question, and he's thanking you for the talk. And he asked, can you truly define AI art as pure machine art, since ultimately it's a subjective and it's homocentric? By that, he means ultimately it's interpreted through human eyes.
Right. Yeah, it's not purely machine art. Like I mentioned earlier, there is this machinic surrogacy going on for sure. And it's more of, we cannot call it technically collaboration, but it's really working together, machine and human working together. It cannot be done by just machine. It cannot be done by just human, but it needs to be done together. So, but I think the subjective and homocentric point of view come from that maybe at the end, human artist or curator picks which one will be presented as an artwork. But we can actually algorithmically design that process as well. We can make an algorithm who is a curator, which is a curator, and then give a goal that, okay, we want this kind of exhibition, and please pick this type of work, this type of result. Then the algorithm can do it definitely. So we can actually turn the system more or less human-centric. Still, I don't think it will be zero human at any time ever.
That's great. Thank you for that. And thank you, Eyal. Joel has a question as well. He says, what do you think about outsourcing creativity to a machine in an artist's own work? Example, using machine learning trained on an archive of past work. Example, paintings to predict what the next subject might be. Is that a cop-out or an opportunity for unlearning, or is it an opportunity for self-reflection?
So, cop-out or an opportunity to unlearning or self-reflection? Difficult. Technically, this has been actually tried, both in painting and music. So we can actually try to. We can try to. I think we can call it some like surrogacy collaboration, because let's say I'm using Joel Ong's artworks as my data set, and my algorithm learns all the things from Joel Ong's artwork data, and then using what the algorithm learns, I work with the algorithm and then create something, right? Then maybe there is a Joel Ong surrogacy collaborating with me through the algorithm. So I don't know if it's crop out or unlearning opportunity or self-reflection. I cannot tell. I would like to hear your opinion about it. But these actually examples. So in terms of painting, like old Renaissance paintings, there is actually a company doing the X-ray image of the painting. And you know that very often old masterpieces have the first tryout painting, like sketches. They style transfer that artist style using that first sketch out and creating, like they say, revealing buried art. Also, in terms of music, the Beethoven died, I forgot, 9th, so died before finishing his last composition. And very recently, a team of researchers generated that last piece, finished that last piece using machine learning. But art critics are very, very unhappy. Okay, that's not the best word to choose, but they are not, think that those are not, they cannot be considered to be any descendant of that artist's art word. It's just one fun experiment. They really don't accept them, art critics. So Nirvana released a new song this year, I see. So Joel, what do you think? Crop out or opportunity for unlearning or self-reflection?
I don't know. I'll be honest. I mean, this question really arose, I think, because we were looking at some of the numbers from the Sotheby's sale. Was it Christie's sale? And then, it's that kind of stuff where everybody just goes like, you roll your eyes and go, oh, the art world is at it again, like creating value out of thin air, out of novelty, or, something with no real substance. And then you go like, then what is the value, right? If you don't measure it according to what the art world, the market prices it at, right? What's the value? And it's interesting to think about the machine surrogacy thing. And I think about, we've been talking a bit about this relationship that you might be able to develop with a machine. And you can understand a lot about it, right? But the way it understands about you, that reciprocation of relation, comes from it studying your work, I guess. So it might be an interesting thought experiment at the very least to see what the conversation might be if it's trained on your work, I guess. And I mean, it's hard to see how it would develop a subjectivity that is beyond your own. I mean, that's just turning my head inside out, right? But maybe, I mean, to me, that, I share your optimism of machines being a collaborative partner in creativity, as opposed to devaluing it entirely. So I really think this might be interesting new options for us as artists.
Actually, I've been having, my father is in a hospital now, unconscious, and I've been planning to use his paintings. He has so many paintings as data set and generate something and show it to my father, who is a painter. And what do you think? Does this look like your artwork? I just lost that chance at this point, but I'm still thinking to do it at some point. Yeah.
Great. I see Kwame has his hand up.
Yes, there's actually a question here from the YouTube stream from DDL2, who says, thank you. Your talk was very interesting. And they ask, how do you make algorithms? Do you think of them as art projects?
To me, it's an art project, but many of my collaborators are machine learning researchers and machine learning students, graduate students. And for them, it's machine learning project, still research project, right? So they were very confused when I gave them this goal of making the authentic form that's different from anything in the data set, because it's a very completely different goal from any other machine learning researches. But eventually we had lots of conversations and we understood each other. And it's all written Python. And we run the experiment and see what happens and discuss how we are going to improve like this part, that part. It took more than a year actually to do that one 3D sculpture generated. So the real answer, I cannot do it by myself. Machine learning is all math. I want everyone to know it's all math. And the level of math is above my level, seriously. So we do need help from machine learning researchers and statisticians.
That's great. Are there any other questions on the YouTube stream, Kwame?
Nope, just that one.
Great. Hersa Valente, I see your hand up.
Hi, and thank you very much for your talk. It was super interesting, and I really love the concept of the symbiotic ecology of humans and machines that you described, which is perfect. What triggered me the most was when you were describing the generation of 3D sculptures out of arbitrary, intuitive kind of decisions, like the kind of forms that you would put together. And I would like to know, where is that line that separates objective categorization of objects in the generation of form and intuitive decisions made in this in this creative process, and how these two, I guess, can be evaluated in the system that you've been working with for AI created imaginary artworks.
So this is a weakness and strength of this type of collaboration. Because the goal itself is so unique for machine learning students, I had to often give them very direct explanation that, okay, let's do this and that. Okay, let's try that and that. But usually students can try things by themselves and just compare the results with graphs, which one is well optimized, which one has better result, right? But because, like you said, the goal itself can be very subjective and even arbitrary. So they constantly ask me, so do you mean this? Do you mean that? Do you mean this? Right? So I had to give some line, okay, let's do this and this, like toilet and human. Let's do that and then see what happens. But those are really my, like you say, subjective arbitrary choices based on my experiences in my prediction system. And then what could work, what could not work. So if we talk about it from the computer science point of view and try to evaluate, that's gonna be a huge weakness. But at the same time, when there is this interdisciplinary collaboration, if we actually try to figure out what's the best object to use in this case, that case, our goal is not very clear, so that was not possible. So we would not have had any result. I think that's a strength of artists. Sometimes we just do it. So in terms of that, I think that was a good one reason for kind of successful collaboration. So yeah, both ways.
Thank you very much.
Yeah, there are other questions out there. You know, in listening to the conversation, Eunsu, one of the things I'm thinking about as well is, on the one hand, there's the goal of trying to reproduce a credible work of art. So how do we sort of categorize, catalog, understand, learn a set of skills that are going to generate a work that, you know, you could take before a group of experts and say, is this a work of art? And they might say yes. So that's interesting to me, though. At the same time, coming from my own fine arts training, I think it's interesting because we would be resisting all of that cataloging, categorization attempt in some respects when we think about that creative process. But the other thing I wanted to say is that, and the other part that I'm interested in, so I'm interested in that goal, but I'm also interested in the other side where when you were showing some of the oral flora works that you were working on, and you were talking about creating these forms by kind of merging different forms, I'm interested in that as well, because one of the things that I think when I look at that work is I think these feel like they're emerging forms. They feel like they're hybrid. They're I guess what I'm trying to get at is and I don't know if Professor Valente was suggesting this as well, but I'm wondering if it might be possible that the machine's going to produce something new, or it's going to produce something that we wouldn't expect. And in doing that, we need to sort of adapt our way of seeing. And I think in part, that's part of the goal of contemporary art, right? They're looking for us to see something with new eyes. They're looking for us to, you know, reimagine something. And so I'm kind of hopeful that these machine human, collaborations, if you will, might produce new forms, new ideas that, you know, perhaps we haven't seen before, and that we might not necessarily be ready to accept as artworks, but eventually over time, they might be invited into the, I don't want to say into the canon, but, you know, they might be invited into the art world.
Field.
Yeah, they might be invited into the field, you know, as so much, you know, new contemporary artwork is initially sometimes rejected, but then later, you know, we're ready to see it.
I agree with you. So right now there is a huge resistance from especially not only artists, but from art historians and art critics. So actually I'm working with art critic right now to have better understanding about this issue. But aside that, there is one example I like to tell my students. In Go, you know, there's AlphaGo, and there are so many Go programs using AI right now, right? Chess and Go and all these games. Now everyone uses online app to train themselves. So when those Go systems came out, at first, people didn't understand those very unique strategies that no masters tried before. And they like, oh no, the machine is making a mistake, but the machine won. And after that, people learned by watching it. They started using those new strategies. So I actually heard the overall quality of Go field, like what is it called? The ability, the level has actually went up. The average went up after all these practices and learning new strategies from machines.
Yeah, it's interesting to think about how that might translate in terms of, you know, art production, artistic, cultural production, for sure.
Yeah. Although we expect more resistance, but
yeah, that's okay. Resistance is good.
Right.
Yeah. Are there other questions? Challenges?
Okay. I have one more, but I don't want to take up. Anyway, can I ask a real practical question, Eunsu? You know, with your work with women in AI, you know, I know there's some talk about the social cultural dominance of existing databases. You know, what can people what could people like us do in terms of helping to populate databases, or, you know, are there any practical tips that we may be able to do to help this?
I think what we can do at this point is being aware of that. So not trusting the result of these algorithms from those biased data sets, not trusting them. Like there was a case, I think in Ohio, the government was in a hurry a couple of years ago, and they wanted to use machine learning algorithm and using these biased data sets to check criminals, the chance of committing to another crime. Mm-hmm. And of course, that's biased data set, biased result. So we should be aware of it for sure, and we shouldn't be in a hurry because it takes a lot of time and effort to collect accurate data. That's why it has not been done, because even these big companies like Google, Facebook, they have all the money in the world, still they are working on it. So I don't think it's something like collecting the good data set or fixing the algorithm to be more fair. That's more expert level or more bigger organization level work, but at least we can be aware of it. And if there's any chance of collectively, I have this, I don't know if it's possible, but I always imagine collectively, slowly gathering data set together by ourselves with our own will, not just scraped by other big companies. That would be really great. And in machine learning field, the researchers working on fairness, what they do is not changing the data set itself, but changing the mathematics inside and tweaking. If it's like 3 and 7, this 3 should be 5 and 7 should be 5, something like that. So they work in math. So there are efforts going on. And maybe we can just pressure these big companies more. They have all the money to have the right data set, right? To build it.
We were talking about that in my undergraduate class today a little bit. And we were sort of talking about the need for better data, the need for tweaking the algorithms, as you suggest, but also the need to be better attuned to the possibility of data when we're evaluating the results at each stage of the process. You know, we are subject to bias, and at each stage of the process, you know, we sometimes see what we want to see rather than seeing what's in front of us. So, you know, all of these strategies, I think, are important for us to be thinking about when we talk about imperfect data. So, not that the idea that there is perfect data exists.
Human society.
Yes, exactly. Other questions? Oh, Hersa Valente is recommending a book for us here in the chat. Yeah. Hersa Valente, what's the book?
Race After Technology?
Yeah.
Yes.
By Ruha Benjamin, that talks in extent about the kind of biases that have been passed inside the data sets of machines to, as you just described, about like seeing what neighbors of these cities is more probable to have more criminals, or depending on on racial differences that can be found in different neighborhoods. So, and also how this data of like even the simplest of data of your where your address, your first name and your last name, especially in the States, that book refers to the situation of racial issues in the States mostly, and talks about how even like if your first name is American and your last name is something European, like you kind of fit into a certain category, and yeah, kind of, yeah. And
no, it's great.
How it can
Very
be
nice.
used against community.
Thank you, Hersa Valente. Are there other questions out there before we call it a day? All right. Well, Joel, should we say thank you? Okay. So, Eunsu, thank you very much for your talk today. We appreciate you making time for us and sharing the work that you've been doing. And we look forward to seeing more of what you and your students come up with through the courses and you through your own research. So that's
okay,
great.
thank you. Actually, really, it's been really fun discussion here and good questions.
Great, good. All right, everyone. Well, we look forward to seeing you at whatever that next time might be during the week. And thank you again, Eunsu. Bye-bye.
Have a good night.
Okay. Good. Kwame, maybe you can wait for a moment. I don't know if Alessandro is still there.
Maybe stepped away for a moment.
Just stop the live feed.